So I think we have this. Let's read that problem. That's actually a little bit above your, I would say, your pay grade to solve it. But it's not that difficult, and it's very nice. I did this problem with my other 30 to 38 class. So we have an auto insurance company which insures drivers of all ages from 9 to 99, essentially. And you have the distribution of ages into 4 groups. You have a probability of an accident, and then you have the breakdown of the insurance customers into those age groups. So we have a randomly selected customer, a randomly selected driver who has an accident. What is the probability that the driver belongs to the first age group, 16 to 20? If I would like to start with this problem, then the question is, what this problem is. To make it a bit more challenging, I would say I would have put the problem in the following way in an exam. A randomly selected driver that the company insures has an accident. Find the probability that a randomly selected driver from the ones that the company insures is between 16 to 20 years of age if that customer has an accident. So automatically, what does the wording if mean here? It's conditional. And then I started messing up a little bit with my other class, my 3338, and I puzzled them. And I asked them this question. What is the probability that a driver who is between 16 to 20 years of age with a policy in the company is involved in an accident? What is the difference between this question and between the previous question? Mm-hmm. One is if you put A to be the driver is involved in an accident, and I call B1 the driver is between 16 to 20 years of age because that's the first age group. That's why I'm using the subscript 1. Then what you see here, actually this is nice. Let's do the grammar here. Let's work the grammar. What is the subject in this thing?
Drivers of
What is the
16 to 20 years of age with a policy with the company.
Subject. Driver. What does the driver do? He's involved in an accident. So that driver is involved in an accident. What do we know about this driver from this sentence, by reading this sentence?
Age and that he's policy holder. Age and policy holding.
He's a policy holder and?
Age.
Okay, and has an age which puts him into the first age group, 16 to 20. So what kind of probability does this ask? Does this question ask? It is asking about the conditional probability. What is the condition? The condition comes from the modification of the subject. The modifiers, which are the modifiers? If that customer is of 16 to 20 years of age with a policy in the company, or there are 2 modifiers, this and this, and with connects them. So you automatically know that is a customer who has a policy, it's a policy holder, and if you go here, then where you should be looking about that. Second column. Actually, the third column. The third column, if you add those numbers, gives you 1. Correct?
But we know that it's only drivers that are 16 to 20.
You know that this is also 16 to 20. So the other condition, you know that this is among those the drivers that have been insured by the company. And that's the only set you're interested in. And within that set, you know an additional condition which further restricts the sampling space, or the event space, as I would call it. That condition is 16 to 20. Now I'm asking, what is the probability that this driver has an accident if that driver belongs to the first instance? 16 to 20. So there is no need for any calculation. 0.06. I was just messing up with my class. And there were different opinions because they thought, well, that person is not going to ask such an easy question. Well, there was an easy question, there was a more difficult question. If a question is very, very easy, it involves no calculation, sometimes it can be equally difficult because you come with a precondition that I'm going to ask a difficult question. No, I'm probably going to ask a very easy question, which I may consider as difficult, just to make your life harder. Simple as this. To test your knowledge, test your ability to critically think. So here, what I asked them, if we go back, and they saw that only one student was adamantly did it right from the very beginning. Well, the good thing was that I was expecting that student to do it right. So at least I didn't fail in my expectation, in my mathematical expectation. And that person said this, and immediately said this is 0.06, which it is, actually 0.06, which the table gives you, no calculation. So suppose that you have such an easy problem. Just think critically. This can be half of the problem. Just thinking a little bit carefully, without panicking, gives you half of the points in the problem. The problem has 25 points. It gives you 12 points without doing any calculation. That's pure good credit. That's an asset if you can do it quickly and right. Don't think that every question is going to be difficult. No, the questions may come in tandem so that I check your ability to think as well. You're at the junior level and you're supposed to be able to think as well. I'm not going to give you problems that look like everything else you have done all the way. Some, and several actually, most of them will look like the book, but in each problem I may ask a question that actually introduces a small perturbation to the problem. Just to check. So work on problems. If you haven't done all the problems that I've ever posted that I have recommended for study, just go ahead and do them, work them during these 7 days that you have, more than 7 days actually, 12 days until we get together again for the exam. Don't try to limit yourself only, oh yeah, I did the problems of the homework, out of 4 problems I do 3. Well, your probability is not for success, not going to be 75%. In an exam, it's going to be 50% of that probably. So if you want to make a high grade in the exam, you should probably be getting a double of your expected grade in the exam. Double should be the grade that you make in the homework in average. That would be a good rule to think about. Yes.
Monday,
I was planning to have office hours on Friday. Not tomorrow, Friday during the spring break. Just say that I will be in my office for a long morning if you want to see me, or a long afternoon if you want to see me. So I don't wake up early or be able to catch those who work in the morning and they have a free afternoon, and those who work in the afternoon, so they can come early. I will email you. I will send a general broadcast to everybody. That way, on that Friday, before the end of the spring break, I will be in my office. You're welcome to come. Okay? You can ask me problems, you can ask me questions. If there's a small group, I can tease you work problems and so forth and so on. Sounds like a workshop. Okay? But the most important thing is not to see me solving problems. Is to put you, yourself, into action and solve problems. And if you try problems and you can't solve them, just come and see. Okay? Sometimes it's a matter only of showing you 2 or 3 problems, and then you're able to work twice, 3 times as many problems than you could do before. All right? So that was the question. So the first question was this, and the second question that you under the problem was asking was this. And of course, the problem was telling you, oh, the driver had an accident. So once the driver has an accident, what you're being asked is to calculate the posterior probability. The probability that I asked here is the prior probability. That's what we call it. So if we want to ask this one, then that's the calculation. 16 over
101.
What do you mean 16?
I mean 1, 6 over 101.
Oh, okay. And now the same problem, I can do the same problem by using 2 random variables. And if we want to use 2 random variables, then I would use the following random variables. I would use the random variable x, which takes 4 values, 1, 2, 3, and 4, each per age group, with 1 being the youngest age group, and 4 the oldest age group. And then I would put y to take values 0 and 1. I would say 0 if the driver has an accident, 1 if the driver has no accident. Okay, so I consider failure to have an accident over the other way, so you don't get confused. What is this random variable here? What type is this? Well, I write over there, it's Bernoulli. And then what I can do is to calculate the marginal probability for each one of them. Okay, to calculate the marginal of y, you don't have many ways to do it. You can do it only in a certain way, because that's the information that you have from the table. Let's look at the table again. Portion of companies insure drivers. So if X takes the value 1, meaning you're looking at this, what is these values? That's exactly the probability that a customer of the company belongs to this age group. The first one. That probability is 8%. So the second column here is giving you what? Does it give you the joint density, or what does it give you? I want some courageous answers, even if they are wrong. Why estimated? What is it?
You're just asking for your last point.
Yeah, what is the meaning? If I use the concept of two random variables, x and y. What are the probabilities? I define what is x. X takes the value 1 if the driver belongs to 16 to 20 years of age. Takes the value 2 if the driver belongs to 21 to 30. And here it's the highest. So here, what is this? Marginal of x, correct? That's the answer. That's the marginal of x. It's telling you portion of companies insured drivers, which fits what? That is, forget this. The way you should read this is what is in the first line? The portion of the company's insured drivers who are between 16 and 20 years of age. That's exactly the probability that x takes the value 1. And that makes that third column the column that gives you the marginal of x. Okay? Now, what does this second column do? Let's see, what does this second...
Having an accident if you are that age.
Probability of having an accident if you are of that age, correct? So, if... all right, I'm sorry. Let me just interrupt this so we don't get the messages. Yeah, I don't know what it was doing. It shouldn't be synchronizing, but it was synchronizing. I don't want the synchronization because I want to save battery. So let's go to the second column again. Probability of having an accident if you belong to that age group. So if we go back to our two random variables, the y and the x, y takes the value 0 if you have an accident. The driver has an accident. Takes the value 1 otherwise. What should be the second column? It's not marginal. How do we call it? Try. You're not talking to me. You're talking to all of us. So please be loud. Please be loud. You're talking to all of us.
Conditional of x given y equals 0. 0 is perhaps 0.
That conditional of x. The value, what is given you is any other opinion? How would you call this? If forget the accidents and all that, forget the random variables. Let's go back to A and BI, B sub I, the events. B sub I is I belong to the first, the second, or the third, or the fourth age group, and A is to have an accident. If you use the language of events, how would you phrase that? So what would be, if I want to put it in notation, what would be the right notation? Probability of A, that did it before, given B sub I, okay? So if you now want to transfer this to the language of random variables, how would you call it? I mean, the condition is the condition. It remains the condition. Yes? That is correct. Probability of y. So you are now seeing the probability of an accident. So y is the event that is you are assessing whether is going to happen. Y is the random variable of whom the value you want to examine. You want the accident, so that random variable should take the value y 0. So when x takes the value I. So this is nothing else but the value of the conditional of y when x takes the variable I. So if I want to ask you the question, find, using this table, the conditional density of y given that x takes the value 1. What does it mean x takes the value 1? What is the age group? 16 to 20. If I say find the conditional density of y given that x has taken the value 1, what are the values that you need to give me? Y takes only two values, 0 and 1. All right, so if I go back to if we go here, what would you tell me? What are the values that you need to calculate? What do we put for the density here of y? How many values does y take? Two values. So how many values of the density, of the conditional density, do you need to calculate? How many? 15, 16, 17, 1,000? One only? You have to calculate two. The other one can be immediately calculated from the other. You have the value 0 here, and you have the value 1. Okay? That's exactly the 0.06, and that's the 0.94. Because this is density. If you add the two values, because y can take only two values, the sum of these two probabilities should be equal to 1. These probabilities here. So you only need to calculate to know one of them, and that one is given directly from the table. All right, if I ask you find the values of the joint density, what would you do? The joint density of x and y. If I ask you to find this value, for example, 0, 1, no, 1, 0. What would you do? No. What is the conditional density equal to? By definition. Did you forget these things? This is the joint, the value of the joint density at, look, 1, 0. I put 1, 0 because I have f of x, y, divided by the value of the marginal of x at 1, which is the value here. So look how the values move. This goes here, and it goes then here, fills the first coordinate, and this 0 fills the second coordinate. Well, my drawing is not very good, but anyway, I can fix it. It's Picasso-like. All right, so that would be exactly 0.06 times the other value for whom we have the, we know that here is the density, here's the marginal of x, 0.08. Okay, so that value here is 0.08 per think that I go, yes, I want a different page, thanks. You saved me. 0.08, so times 0.08. So that would be 0.0048. So what that probability is here? What does this represent if we want to use the language of events? Intersection of whom with whom? Of Cullen with 59? You don't.
Probability that a 16 to 20-year-old has an accident and is insured by the company.
Yes. So this is exactly the probability that, as we say, x takes the value 1 and y takes the value 0. So the first event means that x here. Probability that driver is insured by the company, by the firm, by the company, and is 16 to 20 years of age and has an accident. Okay? That part is exactly this, that has an accident. All this other part is this, the x equal 1, in concrete form. I'm writing, I'm a little bit messy in my writing, I shouldn't be that messy. I know I'm writing better than you, Martin, yeah.
Because this distribution is of the company, this would be we would have to take out the is insured by a company. Insured by a company would be an assumption because we are only using the sample space of insured by a company. So
yes. Yeah, that's why I put it and insured by the company. Oh, are you talking about the 0.06? It's already assumed, so you can either ignore it or you can either include it. It's not necessary.
You need to have, there needs to be a driver of the company. They need to be insured by a company in order to fit within the data that we have in the information.
That is true, yes. But even if you miss it, it's better if you write needs to be insured by the company. So you use that and there as a modifier because all the data that you saw in the very right-hand side of the table, then those were data that were applicable to the company, whereas the middle line, the middle column, could be applicable to the company or to the general population. If it's applicable to the general population, you say, well, the company goes by these rules, unless it has some exceptional customers, which the problem didn't assume. Okay? So if I ask you, what is the expected what is the expected value of y? If I ask this, essentially what am I asking? You have a Bernoulli random variable, okay? So I'm asking what? For random policyholder to have an accident. Okay? How do we calculate this? You have a random variable, okay? How do we calculate this?
Since this is a Bernoulli value,
yes. One times
the probability of having an accident.
Okay, you don't need to calculate this, you need to calculate this. Okay, the value of the marginal of y when x is equal to 1. How do we calculate the marginal of y at 1? We use the conditionals, the law of total probability. Okay? And or we use essentially this, the joint density. If you don't remember that, just go to the joint density. This is x. X will go from 1 to 4, all the possible values of the first random variable, comma 1. And exactly this is, you remember that the middle column gives you the conditional of y given y taking actually the value 1, given that x takes the value lowercase x times the density of the other one, of the marginal. Okay? Sorry, that was for 0. Yeah, you need this, but the middle column was giving you the value for 0. So this is not difficult to find. Oops, pardon me. Why do I subtract from 1? Because y, when you condition it, will still take two values. Y, even when it is conditioned upon the age, will take two values. Either the customer has an accident or does not have an accident. What changes each time, based on the age group, is the probability of having an accident. This is what the column is giving you. So if we want to calculate this, essentially we have to make all these calculations. The first would be 0.94 times 0.08 plus...
One is that they have an accident?
What?
Isn't one that they do have an accident?
No, I put one that they... yes, one is that they don't have an accident. Okay? That's what I did. One, they don't have an accident. You remember from when I did in the last semester in 38, I did the same problem, but I had reversed back then. This is only one. Is it clear? Did you all understand what I did in this problem? All right, now my next question would be, do you have any problems that you want to ask me? Review for... I'm siding with 4, because problems may have more than one question. Sometimes. Not all problems may have more than one question. Some problems may have more than one question. Not all of them. Excuse me? No, linear regression will not be tested. That was a session for your information only. The histogram not now. We'll do histograms. We'll see histograms later. Yeah, I want you. Neither I will do box plot. So I want you to be able to understand what the concept of the histogram is and what is the sampling or empirical distribution. Either way is fine. It's exactly the histogram is giving you that information. Those are things that we'll need later on for the statistics, but not now. So let me do problem 4, which was in your homework, I think. Telephone calls enter a college switchboard according to a Poisson process. On the average of 3 calls every 4 minutes. Let W denote the waiting time in minutes until the second call. What is the PDF of W? You're waiting until the second call. When you have a Poisson, how the Poisson does connect with does relate to the exponential?
Basically, you take the inverse of beta
If you don't know, how are you going to solve this problem? Had I asked you what is the first, if W is the waiting time until the first call, the first incoming call, what would you have asked? What would you have, how would you have argued? What would be the distribution of W then? Would be exponential. Exponential is until the arrival of the first event. If I had told you, let W be the waiting time in minutes between the first and the second call, what would be the distribution of W? Exponential and Y. The important thing in this, the 25-point question is the Y. Exponential plane would give you no points, probably would give you 3 or 4 points.
Because the function is memoriness.
No. What?
Because
yeah, elaborate a little bit more. Try to phrase it better.
Poison events are independent.
Hold on, he's talking, please. Yes. Go ahead. Can somebody else improve upon that answer?
Poison variables are independent. Each event in the occurrence is independent of another. So one occurring will not in any way affect the chance of occurrence of the next.
Hold on, put a full stop and just try to rephrase in a way that you try to become more coherent in your speech. Okay? Try one more time.
But, this is a Poisson variable. The distribution of events are Poisson. Poison events are independent, so that means that the second event does not in any way depend on the first event.
All right. So it did better. So
one event.
Since I tell you that the calls enter the college switchboard according to a Poisson distribution, exactly a Poisson process here, what happens between the first and the second call, the 0 calls and the first call that comes, and the waiting time that is between the first and the second call are essentially, is like waiting for the first event to happen in a Poisson process because of the independence of the occurrences of events in a Poisson distribution. So if I tell you you are between 0 and first call or between first and second call, the waiting time W is modeled by the exponential because it's like waiting for the first call of a Poisson process, the first occurrence of an event. Okay, suppose that you don't know what to do here, and now you're waiting from 0 time until the second call comes in.
Gamma.
Let's see if it is gamma. Suppose that you don't know. Are you going to panic? Well, probably you could, but I don't think that is going to help. So suppose that me is the one who doesn't know. Because if I say gamma, yes, gamma, but what are the parameters of the gamma? Let's derive it. What I did to derive the distribution, the exponential distribution. So let's say W is the waiting time until the second call. Arrives. So you try to find the distribution of W. That's the CDF of W, the cumulative distribution function of W. And let's say that you try to find that value for A. That's the probability that the waiting time will be less than or equal than A. And of course, this is 1 minus the probability that the waiting time will exceed A. Correct? If the waiting time until the second call arrives will exceed A, what does that mean? This is 1 minus the probability that during the time interval from 0 to A, no more than one call No more than one call arrives, correct?
Wouldn't it be, because this is a more general form, a minus 1 instead of just 1? In this case, it is 1.
No, you know that the waiting time until the second call arrives exceeds A. So that means between 0 and A, this A minutes, no more than one call has arrived. Because if the second call has arrived, then the waiting time would not have exceeded A.
Well, yeah, but if A was 5, then we'd have to change that to 4, wouldn't we? Because as many as 4 calls could happen.
No, look how I described the event. W is greater than, let's say, what you said, 5 minutes. So if, let's say, A is 5 minutes, that means during the first 5 minutes, no more than one call has arrived. Because of the definition of W. Did I understand what you're trying to tell me or not?
I'm saying, what if we change the number of events? What if we allow more events to happen?
Yeah, that's what we're waiting for, more events to happen. Instead of 1, we're going to 2. Correct?
Yeah, but what if it was 5 events in the time?
Then we would have changed. It's a different thing. That would be a different random variable. Now I'm solving the particular problem with 2 events. And I'm going to do this because the calculation is easier. So this is 1 minus. What is the probability that during 0 to A, now you have a Poisson process. This is the probability that the Poisson, that X sub A, which has Poisson distribution. What is the Poisson distribution? What is the mean of this Poisson distribution?
Probability of event times the length of time.
Is lambda, lambda is the rate times the length of time. So you have A minutes, you have 0.75 calls per minute, so you have 0.75 times A. That's the mean of this Poisson. Does not exceed 1, so that gives me 1 minus E to the negative 0.75 times A. Let's see how we can fit things. Times the sum. X goes from 0 all the way to 1. 0.75 times A to the X power divided by X factorial. So this will make things here. Here's the calculation. Let's see. Well, for X equals 0, the term that you have is 0.75 times A for X equals 0. And for X equal 1, you have the same thing times 0.75 times A. And that closes. So that's the CDF of W. So now that I have the CDF of W, and W is a continuous random variable, how do I find the density of W? Well, I differentiate the CDF. So the density of W at a particular point A will be the derivative of the CDF at A. So let's differentiate this thing at A. Well, 1 will just go away. We have negative e to the negative 0.75 times A, derivative with respect to A. And the second term again has, well, I'll do it, I can, you have this here. All right, do you agree with me? Okay, now the differentiation from the first will give you 0.75.
Or we could just sum them up and make it 1.75.
Yeah, well, I could have done this. Yeah, I could have done this, exactly this thing, yes. Here's the negative sign. First of all, you have A, which will give you plus you have a 0.75 that I forgot here. times A. And actually, I think, did I do the calculation correctly? I think I did it correctly. Yeah, I'm right. Yes. -0.75, 1, this. So these two terms cancel each other. So we have that. .75 e to the negative 0.75 times A. Oops. Hold on. I made a mistake. They don't cancel. Things don't cancel. I forgot a term. That's a very good thing. I forgot the A here. What cancels then? The first and the second term cancel. And what remains is the final term. What function is this here? So you have f of w of a is equal 0.75 times a e to the negative 0.75 times a. That's exactly gamma. If you want to fit it to gamma, look at the table. Okay, so what should be? Let me put it into the phrase, into the phrasing of the table. I will use w 0.75 x e to the negative 0.75 times x because a and alpha will not be distinguishable here. That's why I'm switching from a to x. What would be the value of the gamma? What would be the parameters of the gamma distribution here? Let's see. What the gamma, it's not bad to take it from the table. That's what I'm doing. So just do what I do. So copying from the table, you have x to the a minus 1, actually alpha minus 1, e to the negative x divided by beta. So what are the appropriate values of alpha and beta here that you have? Okay, alpha is 2 because you have x to the first power. So that automatically is telling you alpha must be equal to 2. Okay, what is gamma of 2? Gamma of an integer number is the integer minus 1 factorial. So it's 2 minus 1 factorial, which gives you, as usually, 1. That's why you don't see 1 over 1 here. What is beta here? Beta will be the exponent, will be the factor in the exponent of v.
Wait, shouldn't that be 0.75 squared?
No, why?
Because isn't it lambda to the number of events that we have?
No, we didn't go to the second. It was up to one event. Okay? So you have 0.75 times x. You want the beta to be in the denominator. So we know that alpha is equal to 2. Two minus 1. E to the negative, you have to put x divided by 1 over 0.75. So that's your beta. 1 over 0.75. Which is the 4/3. Okay, now what about the beta to a? That's a good question here. That's a good question. So what is beta times A here. We said that beta is our point. So that's our beta. So if you take beta square, that should be this squared. So you would expect to have 0.75 square. Here I would expect to have 0.75 squared. Did I miss anything in the calculation? Oh, that's what you said?
Yeah.
Oh.
Two events.
Where did I miss it? Where did I miss it? Oh, I see here, yes. You see, my calculation already had a 0.75, and then I would get another 0.75 by taking the derivative of the exponent. So that would give me the desired square here. So it was here, this one. So everything is fine. So it is gamma with parameters alpha equals 2 and beta equals 4/3. So what is the expected value? If I ask what is the expected value of gamma here? Suppose that I ask what is the expected value of gamma. You could have answered the same thing directly. What did we say that gamma is? Waiting time until the kth occurrence occurs in a Poisson distribution. That's one of the significances of gamma. In general, it's lifetime. But lifetime is waiting time until your death. That determines your lifetime. Okay?
That would be an exponential function.
So that's why we say that gamma also models lifetime. But when... No, exponential is waiting time until the first occurrence. So lifetime, lifetime is exponential because you don't die twice. You just die once. So it's the occurrence until the occurrence of the first event, your first death. Now, if you wait until the successful occurrence of the kth event in a Poisson process, that of course gives you the gamma. What is the analog of the gamma in the discrete case for discrete random variable? Negative binomial. Don't forget this connection. Had you made this connection in your mind, you would have said immediately, this should be gamma. What is the position? What are the appropriate, as we saw here, values for the gamma? What is the significance of the two? The alpha parameter? That's exactly the occurrence of the second event. So that alpha was the second event that you were expecting to occur. What was the parameter for the beta? The beta parameter was the average waiting time. You had a rate which is 2/3. What happened? Yeah. You have a rate of waiting time for the Poisson, which is 0.75. Okay, so that beta comes from inverting this 0.75. You have 3 calls per 4 minutes, okay? It says 3 calls every 4 minutes, 0.75 per minute. The average waiting time for the occurrence of the first event is that what the beta is. It's exactly the same as in the exponential. But for the Poisson, it comes into the square because we have the second event. And that actually gives you the gamma. And the 1 over gamma A is just the normalizing factor, as we call it. It's if you take only the other part, that part that you integrate, then the integral from negative infinity to infinity, or from 0 to plus infinity because waiting time, will be a number which is big. It's greater than 1. To normalize this number, you divide by 1 over gamma alpha. That number, if you integrate this quantity from from 0 to plus infinity, that's exactly the value of the gamma at alpha. That's how we derive the gamma distribution. It's a normalizing factor, we call it. Is that a little bit understandable? So what is the probability of waiting more than 1.5 times? 1.5 minutes with this gamma. How do you calculate this? This is 1 minus the probability that W will be less than or equal than 1.5 minutes. So what is this here? This is the cumulative distribution of W. Evaluate at 1.5. Now, do we have the gamma tables anywhere?
Don't we just convert this back to a Poisson distribution?
No.
I mean, this is the same as probability that no more than 2 occurrences happening, and when we adjust lambda so that it's 1.5 times the value of its current value, so that we change the time from 1 into 1.5 minutes, and it's set the number of events equal to 2.
Oh, you have, yeah. That's easy to integrate. Yes, this is okay. This is an easy integration. You can do this integration. Otherwise, if you don't have those, you need gamma, and I'm not going to give you such a problem with complicated gamma. When the gamma parameters, the alpha parameter of the gamma is an integer, you can do integration by parts. If the alpha parameter is not integer, then you actually need the gamma. And I have to give you the values for the gamma. So you can do that.
So that integration by parts, though, you can just use this is the Poisson. This is the chance that in 1.5 minutes, the Poisson value takes either the value of 0 or the value of 1, nothing higher. That is exactly the chance that the waiting time for the second call is less than 1.5.
You can do that as well, yes. But I prefer to go with this. So you have 1 over gamma of 2.75 square here. Since you derived it, you can use it if it doesn't disappear. X e to the negative x divided by 0.75 dx. And you do integration by parts. Where do you start to do the integration by parts? What have I said? You start always from the exponential. So that's the first thing that you start with, because if you start expressing x as the derivative of x squared over 2, then you will waste the exam and you will not solve the problem. Actually, you're going to waste all of your college life and still not solve it. I believe, but by the end of your college life, you give it up because you will keep raising the order of x. Okay? So this is with these factors, we always start with the derivative of the exponential. We express the exponential as a derivative of something. You have to repeat because I didn't hear you.
Shouldn't the 0.75 be on top and squared because it's lambda?
I'm going to stop here.